Awesome. Well, thank you everyone for joining, and I would like to say a big thanks to Soligent. They really promoted this presentation, brought a lot of people on, or we're just really excited to be partnered up with them again and getting batteries shipped out. So I like to start all of these presentations kind of out on the same note, and that would be just a little bit about battery chemistry. So when we talk about battery chemistry, definitely when we're talking about lithium chemistry, we tend to have this stigma around lithium ion. We tend to think of lithium ion as a single entity where every single battery that is lithium ion is the same. This is kind of a handy chart I use that shows how that's not true, how there's different types of lithium chemistry. So if you look at these, you'll see some kind of familiar names like lithium iron phosphate, which is what we use here at SimpliPhi Power, lithium nickel manganese cobalt oxide, manganese oxide, nickel cobalt aluminum, tons of different batteries. You'll see a common theme amongst these ones up here. That would be cobalt. So the big difference with lithium iron phosphate is it's a non-cobalt based battery. So what are the big differences looking at this chart? Probably the biggest difference, thermal runaway. So we're talking, laptops, cell phones, things like that, heating up and even catching fire sometimes. Well, you'll notice that lithium iron phosphate is one of the only chemistries that is not prone to that thermal runaway. So it cannot catch fire. It can get hot, but it can't lose that heat mitigation and run wild in order to kind of cause damage. The cobalt-based lithium batteries tend to have that thermal runaway where they do have the chance of catching fire and oftentimes require things like safety, cooling, thermal monitoring equipment, things like that. We don't require that in our battery because we don't have that chance of thermal runaway. Some other big differences, you'll see toxic. We are non-toxic and we are also landfill safe. So that's definitely a big advantage when it comes to manufacturing and as well as the end customer. Okay, so even after we've kind of decided on our chemistry that we're going to use specific in that lithium ion realm, we also need something to house that chemistry, a form factor, really the building block of any battery. So you'll see here we've got three kind of main building blocks. This would be cylindrical form factor, the pouch form factor, and the prismatic form factor. These are all used to manufacture batteries, whether it's something as small as using a single pouch cell in a laptop battery, or using a ton of cylindrical cells to build out a building block like our 3.5 kilowatt hour batteries. So as far as the pouch cell goes, we'll start there. Again, think laptops. That's really kind of the common use of a pouch cell, even some cell phones. These tend to have some kind of issues swelling. Oops, excuse me there. These can tend to have issues swelling, which is never good on a battery. You'll notice the positive. So if you see my arrow here, positive and negative are just simply these tabs. So there's definitely a lot of chance for short circuit because of that. Prismatic cells, I don't see them as much anymore, but definitely in the past, these are widely used. They're a little bit blocky, kind of hard to work with because they really do not leave you a ton of room when you're actually putting a lot of, so say you need 16 of these in series, well, you're kind of limited on what the battery is going to look like in the end. And the cylindrical cell, as easy as it is to think about, basically just think AA battery. That would be what I would consider a cylindrical form factor. Now with lithium and with the scale that we're building on, they're definitely a lot bigger than the AA, but it is basically the same form factor. So what we find kind of useful about these ones, built-in short circuit protection because of where the positive and negative are, as well as, hey, real quick, so I got a question here that came up. It says, I was cutting out a little bit. Can somebody, just maybe anybody want to type into the Q&A if everyone is experiencing that same issue? All right, perfect. Jim, I think that might be on your end then. I would just double check your connection. Thank you, everyone. Awesome. Okay, back to the cylindrical cell. So a big thing with the cylindrical cell is they fit really nicely when we're building out these large blocks. They do leave a little space in between, but nothing we can't handle. And they definitely end up with a smaller, more energy dense battery overall when using that. They also tend to show the longest lifespan. So SimpliPhi Power, we test cells as much as possible, definitely in different form factors, to make sure we still are using the best form factor for our lithium iron phosphate. Okay, so I've already given it away, but SimpliPhi Power uses lithium iron phosphate, or LFP chemistry, and we utilize a cylindrical form factor. So because of this, we can kind of stand behind a few things in our warranty. So first and foremost would be our cycle warranty based on depth of discharge, or how much of the battery's energy you're using. So we warranty 3 different levels here. And I'll kind of go into later why you'd pick each level, but for now we'll just examine exactly what they are. So at 80% depth of discharge, we warranty 10 years, 10,000 cycles. At 90% depth of discharge, we warranty 10 years, 5,000 cycles. And at 100% depth of discharge, when you're using the entire battery's capacity, we warranty 3,500 cycles at 10 years. It is whichever one comes first. So I will definitely go into that in a little bit here. There's a slide coming up that really explains how to utilize these in order to maximize the customer's use out of the battery within the warranty period. You also see something called end of life in our warranty. You'll also see this in other warranties as well. If you look at an LG Chem or any other type of lithium ion battery like that, you'll find an EOL, or end of life. Really what this is we're warranting 80% EOL at this warranty period. So say you used 80% depth of discharge for the battery, and at that end of 10 years, 10,000 cycles, we're saying that you would have at minimum 80% of the battery's original capacity. So I encourage you to look into other EOLs. You will definitely find that 80% is about as high as it's going to get for a 10-year warranty like this. So some are way much lower, which is, it's good to kind of dig a little deeper into these warranties and see what other companies truly are warranting for both cycle life, EOL, and you'll even hear the word energy throughput, which is just a fancy word of taking this cycle number and multiplying it by the battery's capacity. All right. So we also have, I kind of talked about this earlier, but we have no chance of thermal runaway, so we kind of we can operate in a bigger temperature window, definitely on the high end of things. So you'll see an operating temperature, -4 to 140 degrees Fahrenheit. That means whether we are discharging the battery or if it's just simply in standby. You also see charging temperature, probably a bit more relevant, I think, when it comes to most systems. This is 32 degrees Fahrenheit to 120 degrees Fahrenheit. Or for anyone that's using Celsius, that would be 0 degrees Celsius to 49 degrees Celsius. So this allows us for no need for coolant, for HVAC systems, or for ventilations. As far as the low end of temperatures go, I know we've had a lot of questions. I've done some trainings up in Canada and even the northern areas of these states where this low temperature has been a factor. So if you are working on a project, let's say that maybe does require some pretty low temperatures for the battery to operate in or to charge in, let me know. We do have some kind of easy workarounds and solutions to make sure that you stay within that warranty. All right, each Phi battery also comes with an integrated battery management system. So this is pretty much any product you buy from us is going to have this embedded into it. So the management system is an internal battery management system, meaning that it does not connect to the inverter current. What it really does is adds a level of protection to the battery in order to kind of ensure that we can protect the battery in situations the battery's not going to like. So let's go into the exact protection that BMS would try to do. So charge and discharge protection, short circuit protection, and overcurrent protection. The idea being that if it did see any of these types of, maybe let's say too many amps were coming into the battery from a solar array, the BMS will try to turn the battery off in order to prevent damage. It does have its limits. If you push, 500 volts into a 3.5 battery, it's not going to be able to handle that. So there is limits to the BMS. If you continue to push it over and over past its limits, it can damage the battery management system, which is never fun. Cell balancing is probably the second biggest thing that the battery management system does. Lithium cells in general just kind of want to stay out of balance. So this management system bleeds off resistance in order to keep the battery balanced on the top end of things. Okay, so let's talk a little bit about the key features of our batteries. So fast and adaptable discharge rating of C/2, or our power capacity. So I just like to read this word for word, excuse me, as it's kind of just it's a really good definition of a C rate for those that don't know. A C rate is just a measure of the rate at which a battery is discharged relative to its maximum capacity. So the example would be a C/1, or sometimes they call that 1C just to make it confusing. Means the entire battery's capacity can be discharged in 1 hour. So if you have a 3.5 kilowatt hour battery, you would be able to discharge 3.5 kilowatts per hour. So you'd be able to discharge the entire battery in 1 hour, or charge the battery in 1 hour. C/2 is what we rate our standard batteries for. So any standard SimpliPhi battery is rated for a 2-hour charge or discharge, meaning that if it is a 3.5, you can charge at 1.75 kilowatts or discharge at 1.75 kilowatts. So this kind of helps on a few fronts. I would say the biggest is when we're talking, let's say, maybe solar charging or something like that. We can utilize a larger array, less sun hours, and really get that battery charged as soon as possible. Generator runtime as well can be cut down significantly. And even if you're maybe charging from the grid for a backup system, again, 2 hours, we can get that battery fully charged. As far as discharge goes, it helps us kind of have a relatively smaller battery bank compared to maybe, let's say, like a lead acid, where you need this huge bank to fit maybe an air conditioner or something like that. Our batteries can handle that continuous power, as well as they can actually handle twice the continuous amount for 60 seconds. So let's say a 3.5 kilowatt hour battery, just to go back to show you this battery right here, kind of our standard, which I'll go into all the products here next slide. This battery can technically handle 60 amps DC for 10 minutes. So that's each battery. So if you have a lot in parallel, we can handle these heavier, maybe air conditioning loads, well pumps, things like that, without needing a huge battery bank. All right, let's talk a little bit about scalability and expandability. So as far as scalability goes, we do manufacture our batteries at the set voltages. So if it's a 12-volt battery that you buy from us, it is 12 volts. The single module is 12 volts. It's 24 volts. Again, single module, 24 and 48 volt the same. So we're actually running each of these batteries in parallel. The good news is, unlike a lead acid where you might be used to only being able to parallel 1, 2, 3 strings, maybe 4, we have no limit as far as we can parallel these batteries. We don't lose efficiency at all, and we can scale up with any of our batteries basically to meet the energy demand. Expandability, I think this one's probably my favorite about our battery, and this is the ability to actually add on to a battery bank later. So the example here being, in 2013, we see 8 SimpliPhi batteries, 20.8 kilowatt hours. And then in 2015, actually late 2015, so almost 3 years later, we ended up with 41.6. So this installer came back, the customer's needs grew, they needed more power, more energy. They were actually able to add on new batteries to the old. I often get asked, what's the time frame on that? 5 years really is a good kind of rule of thumb. You don't want to go ahead and add new batteries to a system that's over 5 years old. But this can be really helpful whether we're sizing an off-grid system. If the calculation was a bit off, maybe your customer didn't give you the exact needs they had. Maybe they skipped a few of the loads that were in the home. You can always add on some batteries, which is really helpful. You're not staggered to whatever you put in the very beginning. As far as scalability, as I mentioned, we can really scale up to any kind of level here. This is a good example of a 48-volt system. So these are each 48 volts, 3.5 kilowatt hours, scaled up to 300 kilowatt hours just by running these in series to various combiners. As well as you'll see, this is a great example of orientation, which we'll talk about later, where not every battery is on its on the right side up. Some of them are on their sides, and they're all kind of arranged differently. Okay, no maintenance. True with almost all lithium batteries, they are maintenance free. No off-gassing, no watering, anything like that. These are hands-off batteries. They also have very low self-discharge rate, less than 1% per month. So this means that they can idle very well. So if it's a backup system, maybe the energy you put into that battery should be there when you need it. So they definitely aren't just going to discharge themselves over time. If they are sitting without even being attached to a system, same thing. Maybe they're in a warehouse, maybe they're coming from a distributor. They will have that same charge that they left with. They really don't lose a lot of charge just sitting there like your car battery might. So obviously we picked the most drastic picture on the left here, the drastic case I should say, because this is actually before and after. But I've definitely come across a few lead acid banks like this as my time as an installer. So you'll see it where there's a lot of corrosion, cables are kind of going all over the place. It's messy. There's a battery box, probably some sort of vent fan, as these look to be flooded batteries. So this was the system that was replaced with these 8 batteries. So you can see they cut down on size, almost a third of the size. And this system on the right here, the SimpliPhi system, actually had more energy and more power than this giant battery bank of lead acid batteries. So you can see they've kind of cleaned it up, put it on the wall, cabling is cleaned up. So definitely a bit of a cleaner system, more energy, more power, less space to take up. Okay, real quick, I want to go through our basic products. These 2 products are probably our biggest selling products, the 2.7 kilowatt hour and the 3.5 kilowatt hour. These both come in at 24 volts and 48 volts. So they do come at 105 amp hours at 24 volts and 52 amp hours at 48 for the 2.7 and 138 at 24 volts and 69 amp hours at 48 volts. So this is for our 3.5. The 3.5 is probably the biggest seller, but the 2.7 as well. Basically, these are small building blocks. You can see that the numbers are staggered. Why this is 2.7 and why this is 3.5 is to fit any energy need that is really required. So the idea to build out a system using these smaller blocks and not be tied down to a larger building block. And again, integrated battery management system, integrated circuit breaker as well. You'll see one here, and there's actually one on the top here. This helps when you're installing, as you can actually turn that breaker off and the battery becomes cold. You don't have to worry about touching the energized leads or anything like that. All right, another big product is our access line. This is plug and play. It's an all-in-one system, so it is batteries and inverter charger all built in. It can be DC coupled or AC coupled. And this is NEMA 3R rated, so it is outdoor ready. This could be shipped on site. Everything's wired, programmed, ready to go. I've got a whole section coming up here, kind of towards the end, regarding the access unit. So stand by for that, but I've got a lot more information coming on that specific product. And also, so we have some smaller products, like these expeditionary products. These are smaller portable power, emergency power. We're still utilizing the same chemistry. Sometimes the smaller products will have a bit shorter of a warranty. Sometimes it'll be 5 years instead of 10, so keep that in mind. But not pictured here, we also have some smaller 12 volt and 24 volt batteries. I think one is a 675 watt battery and a 1300 watt battery. So some smaller products for things like, some smaller systems, or even just like an RV, things like that. All right, so I'd like to talk a little bit about sales before moving anywhere. I think it's important, whether you're the installer, the salesperson, the designer, everyone plays both cards, I think, in this industry sometimes. So it's important to know how to compare our batteries to others. So we talk about levelized cost of energy. This is kind of becoming quickly the formula we look at when we want to examine not just the upfront cost of a battery, but how the cost is over the lifespan of that battery, as far as what's warranted and what a customer is truly going to get out of a battery. So this is really the kind of equation we use. This is pretty straightforward. Price over the capacity of the battery, the cycles warranted, the efficiency rate, and the desired depth of discharge to get usable capacity. You can also add an ancillary cost, such as, if you have the specific site, the installation location is going to cost X amount of dollars for shipping, things like that. That always could be factored in as well. So this is an example of that equation being used. You can see here, this is our 3.5 MSRP in this case. The MSRP is what I would use because I don't have a cost to compare to. If you are an installer buying from a distributor, you would be able to put up your SimpliPhi 3.5 cost versus your Discover battery or whatever it may be that you're comparing to at that exact rate that you get it for. But in this case, MSRP, we do that over the kilowatt hour capacity. So in this case, 3.5. In this specific example, I wanted to use 90% depth of discharge. So using 90% depth of discharge, we know we only have 5,000 cycles warranted. So we add that in as the cycle life. Efficiency rate is 98% of our batteries, and we get 20 cents per kilowatt hour. So this is really a way to look at the battery over time and not just upfront. This specific lithium competitor we went up against in this comparison, I won't name the name, but it was less expensive upfront, but ended up being more expensive overall due to a lack of warranted cycles and expected lifespan of the battery. So kind of a cool new tool. I don't have it linked here, as every time I hop out of any PowerPoint during these webinars, it's a disaster meltdown. So we do have, if you go to our website, under support, under tools, you'll find the LCOE calculator. It is a calculator that you can just put in whatever numbers you want. You can put in your own cost of our batteries that you're getting. You can also put in competitors, and it'll help you calculate these numbers so you don't have to go through the math yourself. So I encourage you to check out the tool. It's a really cool one, and it's kind of fun to play around with when you're looking at comparing various batteries. All right. So as we kind of start diving in a little bit more to installation stuff, we'll start with battery sizing. So I mentioned earlier 3 different levels of warranty, why you'd use each one. So you can see here they're laid out again, just as a reminder: 10,000 cycles at 80%, 5,000 cycles at 90%, and 3,500 cycles at 100%. So why would you use one of these versus the other? Really going to be dependent on your mode of operation. So if we look here, let's say we have a battery backup system. It's grid tied. They only want to use the battery when the power's out. Well, let's say we use 90 Actually, let's just say we used 100% depth of discharge. That would mean that we have 3,500 cycles warranted within a 10-year period. So you'd want to hit that 10 years before you hit the cycles. And with like a system like a battery backup, where it's just coming on when the grid's down, you're easily going to stay within these 3,500 cycles over that 10-year period. Let's talk the exact opposite, an off-grid system. You'd want to utilize all 10,000 cycles. You might be charging and discharging every single day, maybe even sometimes twice a day. So you want to make sure that you have as many cycles possible within that 10-year period as you can get. So you definitely want to expand the life of the battery by going with this. If you have to just kind of pick a default, 80% will extend the life of your battery beyond this warranty a lot better than maybe using it 100%. All right. Another quick rule of thumb, always contested one, but an easy guide if you just follow it, and that would be to think about inverter sizing. So if you have one inverter and 100 batteries, it's not a problem at all. Obviously, you have maybe some charging issues, but it'll take just quite a while. But there's not really a maximum you can put onto an inverter, but I definitely like to say there's a minimum. So if we look at this case, we have an inverter. This is a Radian GS 8000, so 8,000 watts of continuous power. So we really kind of need to think, if we want to stick within that C/2 guideline, meaning each battery can only pull out 1.75, we just want to size the battery bank to twice the inverter's output, C/2. So in 8,000 watt inverter, we do 16 kilowatt hours of battery minimum. This could prevent any sort of over discharging, anything like that. I get it all the time where somebody will say, well, I've got an 8,000 watt inverter, but the customer only pulls 3,500 watts. Well, if they only pull 3,500 watts, I would just recommend going with a smaller inverter in that case to prevent any sort of damage to the batteries. You'll also, maybe let's say there's a scenario where you have one battery. So I know those come up all the time. Maybe it's one battery. You don't want to find an inverter that's that small. So maybe you find a 2,000 watt inverter. So it's only slightly oversized for that one battery. What I would recommend is utilizing inline breakers, things like that. I've got a whole presentation kind of coming up on some more advanced modules soon that goes into how to do that, how to add that level of protection. So if your inverter or your output is oversized, you can still protect the battery by putting a kind of breaker here, some extra level protection. Okay. Hey, for those who have joined later, I see some hands raised. I can't actually answer questions over the hand raising. So if you do have any questions, please just go ahead and type them into the Q&A. And at the very end, we have some time left to go through each question. Thank you. Okay. So let's say we are doing lead acid replacement. I mean, I know it's still definitely a big business to get into when doing installation. So these are some of the things we consider: the efficiency of the battery, the actual usable capacity of the new battery, no heating and cooling losses, and of course, you can always rerun load calculations. But I'm not going to bore you too much with this since we've got, there we go. Since we've got some guides for this, but basically this is kind of showing how when we use this 3.5 kilowatt hour battery at 48 volts, and we're trying to replace this 450 amp hour 48 volt AGM. So the kind of important things to keep in mind is, depth of discharge, efficiency. So we can see here, we're using 80% depth of discharge. We get the usable capacity of that battery. We take the total capacity of this battery, divide it by the usable. And in this case, we notice that this large bank, 450 amp hours, 48 volt AGM, could be replaced with 4 of our 3.5 batteries. If you are doing any sort of lead acid replacement, or even just need to kind of get a battery sizing, we do have a kind of one pager that goes over exactly how to size your battery on different various parameters, like a solar array already existing, or a lead acid bank that's already there, or even load calcs. or we have our own battery sizing tool as well online. So I encourage you to use it. It's kind of a handy tool that will spit out a number, and then you can bring that number to our application engineers if you need some further help just to double check the project. Okay, so using our product with solar, probably the biggest use case for a lithium iron phosphate battery. We can go AC coupled. Slowly and surely, AC coupled seems to be a very fast growing market now. It was slow moving, and now it is really starting to pick up. So, we're taking existing PV array, and this is just straight grid tied PV array. We're adding maybe a battery based inverter in line with the battery system, and we are able to disconnect from the grid when the power goes out, not only discharge the battery, but bring this PV array back online. So AC coupling with our batteries, huge thing that I see all the time. If you want to make it super easy, we can actually offer the AC coupled access solution. So this is already ready to be put in line with a grid tied array, and also sits outside, which is really nice. DC coupled, still used plenty. We're talking charge controller utilization. This could be grid tied, it could be off grid, but battery based inverter, charge controllers. If it is grid tied, it still has that ability to disconnect from the grid, have PV and battery, and function kind of in an island setting. We also offer, as a little side note, a DC coupled access as well that comes with charge controllers, inverter, and batteries already built in. Okay, so some key benefits. Why you might tell a customer that it's worth going with just going with a battery over just going with a grid-tied PV array. System functionality, the ability to use advanced features like cell, time of use, peak load shaving, utilizing daytime PV production. So maybe we are, let's say we have something like a large PV array that you want to charge up and then maybe dump into a car when you get home, like an electric car. I've seen that a few times as well. And probably the biggest one, if you are trying to sell somebody grid tied, is energy security. So versus just a standard grid tied system, grid tied with battery backup is going to offer that level of energy security. All right, there we go. All right, now the fun stuff, at least fun for me. Installation. So first and foremost, if you need anything as far as manuals, spec sheets, integration guides, we tend to stay pretty paperless, so just please go to our website to grab all those documents. The most important, I would say, is the integration guides, which are basically just show exactly what a manufacturer like maybe Schneider, Outback, SMA is saying as far as settings, and exactly how to program those settings into a system. So I'll go into kind of an example of that here coming up. Okay, shipping and receiving, step number one. It's important that you check the batteries for damage right away. Oftentimes you have to file the shipping claim through the shipping manufacturer, through the shipping company, and not through SimpliPhi. So it's important that you check these right away. I always like to say take a multimeter to it. I've seen it happen where maybe a customer has received a battery that is 24 volt and not 48 volt, or something was crossed on there. So just double check the battery right when you receive it. Okay, mounting. We basically have no clearance requirements that I know of. These batteries can sit flush up against each other. You wouldn't want the leads touching, but as long as the boxes are up against each other, that's completely fine. You can always utilize our brackets. So you can see here, these are SimpliPhi's brackets for wall mounting. Not a requirement as far as wall mounting, but it's definitely kind of an easy to use tool that's already ready to go. You can always use a rack, a battery box, shelving. I've seen so many different ways. We're really not picky about how you place these batteries. As long as it's up to code, and most things are with these ones, you're good to go. As far as orientation goes, I mentioned this a little bit earlier, you can put them on their sides. So they don't always need to be upright. They can be even mounted on their sides as well. All right, Parallel wiring. So I mentioned kind of running each 48, let's say we're using 48 volt modules in parallel. Well, it's important that we utilize this method versus maybe a traditional wiring that you might use on like lead acid or even other types of lithium batteries. Basically what's happening here is same length, same wire, each running up to a positive connection, whether that's a bus bar or whether that's just a connection point. Same thing with a negative here. So instead of jumping from battery to battery, we connect everything to a common here. So this is kind of a single line diagram of that happening, utilizing a combiner box to make that DC connection. So each battery running with 4 gauge to a combiner, and then 2-aught out of that combiner into the inverter itself. The idea here is that we can cut down on wire sizing as well. And the most important part of this design here is we can evenly charge and discharge the battery, even when we have these large parallel banks. So if we are building out a larger bank, we can always utilize a combiner box. Like this is the Midnight combiner box. I know Outback makes a really good one as well. I'm sure there's tons of other companies that make these. Basically just DC, this is just copper and an insulated box. So I've seen some people build their own custom designs or even use basic DC bus that's just not even housed in a box, but just covered up. I've seen some power panels as well. So let's say maybe you're using the GS load center on the Radian, Outback Radian. That typically has a few landing points already set up on a DC bus. So if you maybe have only 3, 4 batteries, you often can just utilize that connection point. So actually an example of that, so these are the GS load centers here. So each battery is being combined here and then ran out to the various GS load centers to connect to these Outback Radians. So typically these would be connected as well. I cannot really zoom in too much to make sure of that, but this customer specifically, you can see they're using breakers in the combiner box and a surge protector. That is definitely not a requirement. The more protection, the better. I'm never sad about if anyone wants to put that kind of protection in. I actually met this specific customer, and he did mention that I think they had lightning strikes in the area, so this made a lot of sense to have that surge protector and just utilize these extra breakers. Okay, torquing the battery. So you'll see here the torque specifications, whichever way you want to read it. 160 inch-pounds, 13.3 foot-pounds. Over torquing this will damage the battery, so please use a proper torque wrench. I did have a customer recently that continuously was breaking the tops of the terminals. He kept showing me his wrench, read the right specifications, and we couldn't figure out why he was damaging them. Sure enough, it's because he was not resetting his torque wrench after each install, so it had become uncalibrated, and sure enough, he was well over the recommended torque values. He just didn't know it. So don't not only use a torque wrench, proper torque wrench, but make sure to calibrate it, zero that thing out afterwards. Don't just keep hammering on it over and over. All right, so I mentioned the integration guides. Well, this is actually a little excerpt out of one. So here you go here. On the right, we have the Schneider integration guide. This is a little bit out of that one. You'll see basically all we do is take the exact language that Schneider uses in their programming software, and we put a setting to it. We put what we would like to see as the setting. So let's say we go to max charge rate, and we're using a 3.5, so this is out of the 3.5 kilowatt hour warranty. We can see that this is 34 amps per battery. So if we have a bank of 3, we just times this times 34 and add that value in. For the voltage settings, they're all pretty much standard. So you'll see them. We'll try to make sure that this setting is programmable. I know some inverters kind of have like leaps, maybe 0.2 volts and things like that. So we try to work it out through every single product that we integrate with. There's always going to be products not labeled on our integration guides. If you ever come across one of those, just reach out to us. We might even have something in the works, or we're happy to build a new integration guide as well. Some of the advanced features like cell or even the AGS trigger, the automatic generator start, they are not typically listed in the integration guide, as those ones are a bit more intuitive. So if you ever have anything like that, just let us know, and we're happy to kind of work through the different various SOCs and how to understand that. As well as my next advanced module for our training slides will be strictly about voltage, charging, and discharging characteristics to best understand how to manipulate these settings as the installer to kind of give your customer the best experience possible. Okay, I always like to go through this. Within our installation manual, you might come across a clause that is a bit confusing, I think at least. So it's basically saying that you need to fully charge the batteries before commissioning. Well, I would take that as fully charge the batteries before even programming or hooking up the system. That's really not what it is. Basically what that's saying is you would go into your, let's say you had a Schneider system, you program all that settings in, you charge the battery up fully, and then you would go ahead and connect the AC loads. So all it's saying is charge the batteries when you first get them and you're installing them before you connect those AC loads. This helps just kind of get that initial balance and get the batteries off to a smooth start. It also really helps if you're using battery monitors or any sort of tool that's going to read the state of charge. All right, so as I mentioned, me doing a huge presentation just on this kind of stuff about understanding this correlation and how to utilize it. But as a kind of a quick taste to it, this is the basics here, the charge and discharge curves of our 48-volt batteries, whether that's a 2.7 or 3.5. It's really all about voltage here. So some kind of things to look at here. Let's see here, you can see this tail coming down here. Well, you would expect to actually charge our battery. So if we go back, you'll see 56 volts on the bulk. This number is actually going to be coming down in our next kind of round of batteries, but and integration guides, I should say. But we would always charge the battery at a higher voltage than we would expect to see at 100% state of charge. So our engineers put 100% state of charge at 52.5. I personally think that it's a bit, I think the engineers are kind of going off of testing in-house and kind of a controlled situation. In the field, I've seen 53 to 53.3 as 100% resting state of charge. From there, it's a very flat curve. You might notice 48.0 is 0% state of charge. That can be kind of confusing when you're talking to a customer especially. But that is what we'd consider 0% state of charge. So we're talking about a 5-volt window. So every 0.1, 0.2 of a volt really does make a big difference with these batteries. So again, I encourage you, if you are interested in kind of understanding all of this more, understanding how to use these settings, how to understand what voltage to do programming at, attend my next training. It should be on the website now to sign up for. And they are a bit more advanced modules to go into the depths of these things. Okay, let's talk code, everyone's favorite. So as far as batteries are concerned with code, even with NEC 2017, we're not called out too often, definitely not as far as rapid shutdown goes, but we do play a part in it because it is a battery-based system. So if you are going RSS compliant, you need that rapid shutdown. Let's say you're going DC coupled. There's a few options with your system you could always go with. The kind of more traditional first step system, which is the shutoff boxes, utilizing the midnight birdhouse, and kind of going that route. Tygo, Tygo and Midnight actually both make basically just rapid shutdown modules. So these connect to each module and only perform one task. They're not optimizers, nothing like that. They simply just fit that rapid shutdown compliance on a DC coupled system. If you're going AC coupled with one of our systems or one of our batteries, you're probably already good to go. I mean, if you're using an N-phase like a microinverter system or even a string inverter with optimizers, you're already modular level shutdown ready. A quick kind of note, putting our access unit in line or even a battery, just an inverter, battery-based inverter and battery in line does not change anything about you being RSS compliant for that 2017 NEC. Okay, so let's talk about the access. So I mentioned this earlier, we're utilizing our 3.5 kilowatt hour batteries, inverter charger built in, system is pre-wired, pre-programmed, and NEMA 3R, so it's outdoor ready. So application-wise, we could do new installations with these, DC coupled, AC coupled's a really big one I see, so existing PV systems already in place, or even just building a new AC coupled system. Outdoor installation is probably the biggest as far as where you put it, and it's also good for an introduction to energy storage systems. So maybe an installer that's done a lot of grid tied, this is a good segue, as a lot of the work's already kind of done for you. So currently we have two main types of access units, and really the only difference is the parts that we utilize. So you'll see on the left here, this is our Schneider access utilizing Schneider components, and on the right, our Outback access utilizing Outback components. So in the Schneider unit, we have the 6848 XW Plus. This is a 6.8 kilowatts continuous inverter, has a max surge of 12 kilowatts, and has 140 amps DC charger built into it. So if you were to order standard AC coupled, it would only come with the inverter charger, not this charge controller. So this charge controller is the DC coupled optional feature where you can get this charge controller built in. I love this charge controller. It's 80 amps, 600 volts. So you can run huge strings of 600 volts into PV wise. It's about a 4.8 kilowatts output. So that's about the size of the PV array. Obviously you can oversize the PV array a bit when you're DC coupled. But again, if you buy the standard of either one of these, we could just get the AC coupled without the charge control. The Outback system utilizes the GS8048. This is an 8 kilowatts continuous inverter. Has a max surge of 16 kilowatts, so it's definitely a lot bigger. Has 115 amp DC charger built in, and this one is Rule 21 compliant. A quick note, these XW Plus are not Rule 21 compliant. If you are in California, you know what I'm talking about, but soon to be, we're going to be swapping these out with the new XW Plus Pro, which is Rule 21 compliant. So that should be happening, I believe, any day now. They should start coming out of our factory with that Pro instead. So both systems will be up to code for California standards. If you go DC coupled on this system, you get two FM80 charge controllers, so 150 volts max PV voltage input. So a bit smaller strings, but definitely still has a lot of power, 4 kilowatts each. So you have 8 kilowatts of PV you can run with that access. Just kind of a quick diagram showing AC coupled and DC coupled. So if you're going AC coupled with our access, you have your sub panel, your grid tied array here, and here's the grid. So if you're going DC coupled, you're going into the charge controller first, charging batteries, going out here. You'd always go with things like the AGS or the COM box as optional features in order to connect to a generator or connect to the internet. And I'll go into that here in a second. Regardless of if you have a DC coupled or AC coupled, Schneider or Outback access, every single one has an automatic transfer switch built in, meaning that when it sees the grid, it will automatically disconnect. Or when it does not see the grid. It goes in island mode, and when the grid comes back on, it will reconnect to the grid automatically. I've seen some kind of weirder system setups lately where people are kind of not utilizing the way that you can do this by putting the sub panel on the other side. If you put the sub panel on this side, you can definitely utilize that automatic transfer. which is a really cool feature for customers. Okay, as far as installing the access unit, probably the hardest part is it's shipping to you. I mean, it's a big unit. It is a big NEMA 3R enclosure. It's going to ship on its side for safety purposes. And the batteries actually come on a separate box. So they're not in the system yet. All the wiring is ready to go. All you have to do is tie down those leads. So as far as location goes, you can always go inside. I mean, it's no off-gassing, no heat mitigation. There's nothing, no issues like that. You can go garage, basement, utility room, go living room if you wanted. But more than not, I see outdoor locations as the kind of main point of where people are installing these units, because they are NEMA 3R. Okay. As far as like the knockouts and the clearance go, I'll kind of save you the bit on the clearance. Look into the manual if you ever are installing one, but it's basically 3 inches on each side to make sure that you can get around it. 3 feet in the front, you can open the door. And if you have a secondary enclosure, you can always put it next to it. You cannot, kind of a quick note here, I didn't go over. We do not allow for paralleling of these units. You can always add a second enclosure with more batteries. So we do have an optional enclosure that carries 12 3.5 batteries, or up to 12 3.5 batteries. So you can add more energy, you just can't parallel the entire units. They come with 4 knockout holes on each side. So there's 3 1-inch knockout holes and 1 1.5-inch knockout hole, and that's on each side. So there's a total of 8 knockout for running PV, for running a generator, for running AC power. So I mentioned programming wise, it is pre-programmed, so it comes with all the basic SimpliPhi settings. If you want to change a little bit, I know a lot of installers that have done a lot of these systems want to kind of mess around with the programming. You can always change up the settings just a bit, meet the kind of, maybe the customer's mode of operation or desired performance of the battery. So always can change things, but if you do nothing to it at all, it is pre-programmed and ready to go right out of the box. Post-installation, monitoring. So if we do have the Schneider system, we're just utilizing Schneider's monitoring in this case. So this would be the CommBox. Cool system, you get on your tablet, on your phone, wherever you want it. You can see historical data, so you can see how the battery's been performing over time. You can also see real-time data, so you can see, how much solar is being produced, where the battery's at as far as voltage goes, and even things like where the loads are pulling from. Outback, so the Outback access is almost the exact same thing. You can see historical monitoring here, real-time monitoring up here. The only difference with the Outback system is that it's got a really cool feature where you can actually, without even needing port forwarding, if anyone knows what that is, this doesn't require port forwarding. You can simply just log in straight from OpticsRE as the installer and go into the device map and actually make changes to the settings into the system remotely from home, on the bus, doesn't matter where. So it's a cool feature if you're an installer that maybe has a lot of faraway installations. Maybe a customer calls you up and says, hey, I really need to change, I don't like that the battery is discharging this low. You can, instead of saving yourself, you can save yourself a truck roll instead of going on site and just change that setting straight from your home. Okay. So I think these slides are a little out of place, but we'll go through warranty, a few things about the warranty real quick, and then I've got 2 more kind of new products to talk about, and then we'll go into the Q&A. So if you are applying for our warranty services, if you are the installer, we might call on you to help get some paperwork and things together. But typically, you can just kind of apply right through us. You don't have to go back through the distribution. You don't have to go to the person you bought the battery from. You can just request a warranty service right through us. These are some of the things we might ask for. Bear with us if we ask for these. We're just trying to prevent any sort of maybe false RMA. So, maybe the battery really isn't damaged. We just want to make sure that we cover that. Just kind of a side note, as far as RMAs go, returns go, Last year, I want to say it was less than 1% of all batteries sold were actually warranty claimed. So very low rate as far as that goes. But if it does happen, just let us know right away and we can start working towards it. All right, fun stuff, new products. This one's really not even that new at this point. I should probably move this slide up, but this is the Express unit. These are in stock and shipping already. Basically, this is I like to call it the half version of the Access. So it's still in a NEMA 3R enclosure, comes on wheels. It's got some really cool features like a DC quick inlet. So this is actually a DC quick connect here, where you can plug in PV and disconnect PV as you go. For charging the batteries, you could also connect from AC. So think like shore power, like an RV. So we have an AC inlet that can connect right into the unit as well. Comes with 4 outlets for pulling power. So we can actually just plug loads straight into this unit, and 2 USB ports as well for charging things like tablets or cell phones. This is kind of utilizing some easier to use stuff. So obviously if you don't want to go through the trouble of wiring up to a loads panel, this is a really easy system just to put in place where the customer can have it fully charged, move it to where they need to, and plug loads directly into it. You can hardwire into this. There is knockout holes, and we can utilize the charge controller and the inverter if need be. So this comes in 2 versions, the Express 24 volt, Express 48 volt. The big difference is the capacity. So for the 24 volt, it is a 5.4 kilowatt hour energy capacity. And for the 48 volt, it is 7 kilowatt hours. You'll also notice the charge controller that comes with it is a bit different. So this one, excuse me, the 24 volt version comes with the TriStar 45, the Morningstar charge controller. And the larger 48 volt one comes with the PT100 charge controller. That's Magnum's charge controller. The other biggest difference here is this 24 volt version only does 120 volts AC out. The 48 volt version can do 240 out if hardwired into systems. The sockets themselves are geared up for just 120 though. All right, and then the second product I want to talk about, newest to our line, is our high voltage product. So you'll see here, this is per battery module. So we're still utilizing these same battery modules we have been. This is actually a 3.2 kilowatt hour module, but it's still at 48 volts. The big difference is we are not running in parallel on these ones. We are running in series to build up in voltage and then paralleling out stacks to build up in capacity. Still comes with our 10-year warranty. Really designed for large scale microgrids, maybe a large backup system that requires a 40 volt panel with something like, let's say maybe we're using a Princeton Power or I know Ideal Power until now, Dynapower, those larger inverters that want to produce 480 volts AC, that's where we utilize this product. It builds up from 200 to 800 volts DC nominal and up to 2 megawatt hours of storage. So this utilizes a different type of battery management system than our standard product. This is an external battery management system. So you can see here the stack controller, kind of the brain of the operation. And here are our kind of the followers on the BMS where they're each connected to the module itself. So this stack controller is pretty cool. Comes with CAN bus, Modbus, Ethernet ready. So all those communications already built in. It also has the ability to do its own monitoring. So you can actually just do straight battery monitoring without any kind of SCADA network or asset manager. So we can see battery system health, see faults, clear faults, all those types of things can be done straight from the BMS system here. All right, post-installation, then we'll go to the Q&A. I want to give us enough time to get through. I see quite a few questions on the Q&A, so I definitely want to get through all of those. As I mentioned, if you are going through a warranty or anything like that or having some issues, call our tech support ASAP. You know, shoot us an email, whatever works for you. We're always happy to help, even if it's you know, if you're suspecting that maybe it has something to do with how the inverters, excuse me, interacting with the battery, we can always help on that too. So most of our tech support is familiar with not just our products, but plenty of other products as well. If you ever see anything like this, just let us know. Like if a battery breaker is tripping, maybe the BMS is going to open circuit, so the battery is showing little to no voltage, but the breaker's in the on position. Any signs of damage, things like that, just call us as soon as possible, especially if you're seeing things like battery breakers trip. That typically means that something's not sized correctly or there's an issue with the system. So if you call us as early as possible, we can try to help identify what's going on. Okay, I am going to go ahead and pull up a Q&A and see how much of this we can get through. All right, perfect audio, thank you. I see a first question from somebody asking for pricing. I would go ahead and, as Soligent is the co-host of this one, go ahead and ask them and they can provide you pricing. We only sell through distribution. So go ahead and ask them and they should be able to get you a pricing sheet. Okay, sorry, I'm just deleting a few when I asked if I was cutting out. So let me just get through some of these. Better now, I'm okay, thank you. All right, thanks everyone for letting me know I wasn't cutting out there. Oh, last time I was cutting out, okay. All right, where does LFP come on your list of lithium batteries? I'm not sure exactly what that question is asking, but where does LiFePO4 come on your list of batteries? Well, we utilize lithium iron phosphate, so LFP. How is number of depth of discharge to 80% determined? Yeah, so that's really, it's going to be off of voltage. So yeah, I didn't have the slide in here, but if you go to the warranty, it outlines exactly what voltage correlates with what depth of discharge. So for instance, 50.2 on a 48 volt battery is 80% depth of discharge. So somebody in Montana is asking about heating, you know, going outside of those kind of parameters. Yeah, happy to send out some information on that. I've seen a few kind of cool tricks. I mean, most of the time the battery's inside. Rarely is it outside or anything like that. If it is maybe in a box or something like that, it could get pretty cold. But if you're truly concerned, you have an install that maybe fluctuates temperature just a little bit, we can always utilize things like, there's actually battery heating pads that can help prevent any sort of damage. And we can always hook that up to the auxiliary port of the inverter to come on at a certain temperature and things like that. So tons of workarounds. I'll give you my email, just so I'll do that right now actually. So if there's any questions I don't reach, or if you just want to ask me some questions afterwards, my email is Troy, that's Troy, D as in dog, at SimpliPhiPower.com. Feel free to email me directly with requests or things like that, and I'll try to hand you off to the right people or handle it myself. Okay. If the battery was 3C, does that mean the battery can be fully discharged in 3 hours? If so, what happens if you try to discharge fully within 1 hour? Yeah, so I mean, if it's like a C/3 battery, or let's say C/5, I think a lot of lead acids tend to be max C/5. You try to charge at C/1, so in 1 hour, you can completely blow the cells internally to the battery. So definitely don't want to overcharge from what the kind of specs are in a battery. On a side note, if you do require some serious charging and discharging capabilities, we do have what's called the high output line of our batteries, and those can actually utilize greater than C/1. I think they can do like 0.75, so they can actually charge and discharge at 45 minutes. They're definitely not for residential use. I don't see a reason you'd ever need to charge or discharge that fast on a residence, but some military stuff and things like that, we've seen them utilized. Well, that's a good question. So how should one determine the battery parallel wire sizing? For example, if we are installing 16 3.5 batteries in parallel, should we size each wire to the 80 amp breaker or size the 1/16 of what the inverter will draw? Great question. I wish I had a super solid answer for you. To be honest, it varies on code from what I've seen. So your inspector might say one thing in one area and one thing in the other. I know here in Colorado where I live, oftentimes you can get away with sizing to the max battery discharge. So back to C over 2, you would size each battery wire would be sized for that 34 amps DC from the battery. I've seen other places where they will say it's a 3.5 kilowatt hour battery or 69 amp hour battery. You have to size that wire for the full 69 amp hours. So I would ask your inspector, but realistically, there's no reason you should need to size a wire greater than the battery's total output that it can do continuous wise. How do I add this system to a microinverter solar array? Yeah, so you really just need to get that battery-based inverter in line with the microinverter. So you have AC power going in, you're charging, you're actually converting back to DC, charging the battery, and then inverting back out to AC to the loads. Again, if you really want an easy solution, the access does come AC coupled, which is really straightforward, and everything's ready to go wire-wise. All you have to do is hook up the PV and then hook up the AC output. This question about 80% depth of discharge again. Yeah, so what would the voltage be? 50.2. And you can always find that in the warranty document outlines all those different voltages. Or again, I know I keep harping on it, but join me on the next advanced module when that comes up, as it's going to be really beneficial to kind of go over all those different voltage and SOC correlations. State of charge. Okay, let me just read this one. How you determine the DOD? Okay, so it's asking about how we would determine the depth of discharge as far as like if it's a warranty claim, things like that. So really, if it is a warranty claim, it would come back to us. The BMS is internal, so there's no access to seeing that customer-wise. But yeah, we can pull it out and examine those different features and as far as how far the battery is being discharged and things like that. As far as cycles counting, I always get that question. I mean, it's again, we would have to take the battery apart, but I've never seen it happen where the battery is failed due to too many cycles before that warranty period, even when using 100% depth of discharge. This is a question about depth of discharge. Can we see the table again? You know what? Just for you, I am going to go all the way back. So hold on to your horses. We're going to take a little ride here, because we are seeming to talk about that one a few times. Let's go back. Keep going. There it is. Okay, that's the requested go back slide there. Can you oversize the battery in comparison to the inverter? Absolutely. You could have, one 4,000 watt inverter with 100 kilowatt hours of battery. You would need some kind of charging source probably to make sure that you can charge the battery, but the battery doesn't care how little power is being pulled off. The battery will last forever too if you do that one. So there's a question just about me talking about N-phase microinverters on systems already installed. Just speaking strictly about N-phase in general, if you're AC coupling, and if you're AC coupling with our Schneider access unit, N-phase has been the most prominent I've seen used, and it works the best for frequency shifting. So they pair up really nicely with each other when you're doing an AC coupled system. The question will probably come up, which ones don't work? there's only one I found that does not work as far as an AC coupled microinverter, and that is the old Sunbridge ones that were being hooked up to the SunPower modules, the AC modules. Those were not working with the AC coupling on the Schneider or the Outback. So keep that in mind if you have any of those older SunPower modules. I believe recently they've switched over to Enphase, so it doesn't make too much of a difference now. Curious if access can be configured to 230 volts, 50 hertz. Sure can, actually. So let us know if you have any of those requests. But we do have a European model as well. Okay, I don't really understand that one, so we'll skip over it. This question is just, can you go over proper off-grid charging AGS program using state of charge specifically? Is there efficiency derating we should alter the programming battery bank size when programming? I won't go into it too much. Again, I just keep saying it, but yeah, let's join my thing. I'll send you a link. Just shoot me an email. I'll send you a link to join that webinar, where we're really going to dive into that. It's only 30 minutes long, so it's not nearly as long as this because I've cut out a lot of the kind of basics. But we're going to go really hard into how to do proper programming using voltage and state of charge. Oh, I like this one. So when AC coupling with the batteries, with the 5 batteries, what is the limiting factor in designing a system? Great question. So even with the more advanced stuff, where we're frequency shifting, we're ramping down PV, you still don't really want to undersize that battery bank. So if you've got a 4 kilowatt PV array, you really should have 8 kilowatt hours of battery, because with AC coupling, oftentimes it will go unmitigated, and it's just really not a good idea to have unmitigated 2-to-1 ratio where the inverter is twice, or the battery bank is twice the size of the inverter. I'm sure it'll come up if somebody starts looking into our access that we don't follow our own rule when looking at the access unit. So for instance, I think we have 14 kilowatt hours of PV, or I'm sorry, let's say we have 10.5 kilowatt hours of battery on a Schneider 6800. So that's not following our own rule. The reason for that is we are utilizing extra breakers, as I mentioned, as well as doing the programming ourselves at the shop to limit that, to make sure that the battery will never over discharge. So again, if you're interested in learning how to do those kind of things to get past that 2-to-1 ratio, just join the webinar and we're going to go over some really kind of advanced installation techniques. Will the slides be available? Absolutely. I send out all my slides in PDF form after the presentation, probably sometime by Friday, as well as if you want a copy of the training itself. I record every single one, so they will be posted on our website as well. You can always pull this back up. Oh, I like this question. So this is talking about the, let's see if we can find that one. Okay, this right here, this equation, and it said, why are we going by, so it says divide, but we didn't divide by 0.5. It's asking what we're using this 0.5 for here. What we're using that is this lead acid battery can only utilize about 50% depth of discharge. That's being generous. A lot of lead acids I've seen are only 30% depth of discharge. So we're just multiplying the total energy of this battery by 0.5 in order to get the usable capacity. Oops, sorry there. Okay. All right, and I apologize. It looks like we got about 10 minutes-ish, so I'm going to keep going through. There is quite a few questions. So if I don't get to your question, please just shoot it over. Oh, great question as well, Nancy. Can we connect the batteries using bus bars, or do we have to use the conductors / cables? I forgot to mention that. Yes, you absolutely can use bus bars. So you do not need to use that technique of running each battery wire directly up to the bus. You can always use one common bus bar laid on the battery terminals. That's actually how we wire up the batteries in our access unit, is using bus bars. Just make sure to insulate them. You never want to expose bus bars. Getting feedback on your speaker. Apologize. It's never picture perfect on these webinars. Why is it better to use a combiner box instead of battery to battery? Yeah, so because when we're going battery to battery, we basically think of the way that the power actually goes through the battery in that case. We just don't get that even distribution of energy, or sorry, power. And we just don't get a charge and discharge the batteries pretty evenly when we have these large parallel banks. Copy of the slides, yep. All right. So this is just saying, you know, people installing batteries in containers and garages, and what really happens to the battery outside of that temp. That's the warranty temp. I won't say that you could possibly operate outside of that warranty temp, but really, if I ever get an email saying, hey, my battery's operating in 20-degree weather or 10-degree weather, what should I do? I would explain to them that it is not in the warranty to do that, but what we would recommend is turning down that charge rate. So instead of a C/2 charge, now you might be limited to like a C/4 charge. And you might lose a little efficiency on those really low ends. So this says, can Schneider Outback work with N-phase IQ inverters to modulate solar power off grid rather than on and off? I am not 100% on the Outback. I know, so Outback's AC coupling is kind of new again. They did have it for a while. They stopped utilizing it, and now it's back. So let me get with them and send you back a response to that one. But I know as far as Schneider, it's not an on-off feature. It's an actual frequency shift, which does ramp up and down that peak. There's a question about, is there a distributor in South Africa? I do believe so. If you are looking for any specific regions outside of the US, just shoot me an email and I can always help out. All right. Presentation. Oh, this is asking about, please elaborate on the field tests for warranty. I don't think I've ever really made anyone do a field test other than just, so there's a few field tests that maybe I might make somebody do if they have a battery issue, just to make sure that the battery can't truly hold a load and that it is in fact damaged. So sometimes you might do a quick load test where we put a small load on the battery and just kind of measure the amps. So we just want a rack mount for a 48-volt system. Yeah, absolutely. That would be our brackets you can always utilize. You can buy those straight through the distributors. So like Soligent, you can buy straight through them. They'll have our specific mounting brackets to use. Does a high voltage product make you compatible with SolarEdge/StoreEdge system? Yeah, questions come up a few times. I think the issue that I see is, I think the minimum size for battery to fit onto that StoreEdge would be about 22 kilowatt hours. If you're okay with that, I think it should work. If you have a project where you want to use the StoreEdge with the high voltage, shoot me an email. It's something I've definitely wanted to try. I think they've talked with them already, but I'm not sure exactly where that conversation went. But it is not necessarily designed to be used with those smaller residential inverters, but I don't see an issue with it working. Oh, good question. NAPCEP credits. So if you need NAPCEP credits, you'll receive an email from our department, from the training department, regarding this email or this presentation, the slideshow, everything like that. If you are interested in receiving your NAPCEP credits, I have to give out forms by person, so they don't just let me give out a code for you to use. So I have to write everyone a certificate, unfortunately. So just shoot an email back to my email that'll be listed there, and just say, I want NAPCEP credits, or send it to training@simpliphipower.com. And I will build you out a certificate for you to submit to NAPCEP for your credits for this presentation. Also, if you are interested in our program, our IQ program, which is basically become a certified installer, you have a little dot on our webpage, meaning that you are kind of top priority. If a customer comes on and is looking for an installer, you show up on our map on our website. We've got a lot of web traffic. So this is one of the requirements for that, as well as just going to our website, and there's an application to become an IQ certified installer. Please, please, please go ahead and fill that out, as we're going to start getting a lot more of those. You definitely want your blip on the map. If you've done our battery installs before, we want to give you credit for that. Okay. Let's see. Oops, sorry there, hold on. That's a good question, just kind of how does cycles work? I think, I'm not sure if this is the exact question, but if you're using at 80% depth of discharge, a cycle is not 100 watts discharge and 100 watts charged. It's that full 80% depth of discharge, whether it's added up through a bunch of small charge and discharge, or whether it's going all the way down to 80, charging back all the way up to 100. So no, we don't count each little tiny charge as a cycle. Any special type of fire extinguishers needed in case of fire? Hopefully they'll never have a fire. Again, the batteries can't catch fire themselves. That would have to be something electrical wise, like a connection or something. But as far as I know, just a normal fire extinguisher should work. Just not water. But I think that one's pretty obvious. Oh, okay. So when putting a lot of batteries in parallel, do the battery management systems communicate with one another? They act independently? They actually currently act independently. They're on such a small scale, these 3.5 batteries, that they don't need to communicate with each other in order to stay in balance and to charge and discharge evenly. It's actually quite amazing that they don't need to connect like that. So you kind of cut down on all that RS-45 and all those connections and things like that. Okay. Is there a downgrade of voltage settings through the lifetime of the battery? As do we need to change the settings over time? You might see some updates. As far as just performance-wise, no, you don't need to go ahead and change settings as the battery gets older. But we tend to try to send out newsletters. So I know personally I throw newsletters right in the trash sometimes, and I shouldn't. So keep an eye out for newsletters. If we send one out, we do it through there that we maybe updated our settings slightly. So that tends to go across the board for all products. That's just as we have a bigger facility now, we're doing more testing, so we kind of get to see more and more of real world applications. Okay. All right, I think I got time for one more. Let me find a good one here. This was a question about the access. So I'll try to answer two more questions here. So this is a question about the access. The Schneider access comes with either 3 or 4 batteries. You can get it as an option of 10.5 or 14 kilowatt hours. The Outback access only comes in one size, and that's 14 kilowatt hours. But as always, you can always add storage onto that if you want to. So this is a good question. I'm under the assumption of C/20 rating was pretty typical. So definitely with lead acid, that's the typical rating. Lithiums are more and more shifting towards rating at C/2. The big thing here to consider is like a lead acid battery at C/20, there's no reason that you truly are ever charging or discharging at a 20-hour rate. It's pretty rare. So that rating is probably not even what you're getting out of that battery. C/2 is about the same as C/20 with a lithium battery. So our amp hour or efficiency doesn't really change from C/20 or C/2 over to C/20. It might change ever so slightly, but it stays basically the same. So again, if you're looking at like a lead acid that's rated at C/20, I would look at the C/5 or C/10 to get a true idea of how big that battery is. Okay, looks like we are all out of time, and I do apologize if I did not get to any questions. Please, please, please just shoot me an email if you have any questions that I did not touch on, and as well as if you need those NAPCEP credits. Again, there'll be a short email sent out with the presentation, the video link, probably sometime this week. Thank you so much, everyone. And thank you again, Soligent, for putting all of this together and getting a ton of people on the presentation.